Many processes in nature involve randomness in one form or another. Whether we investigate the motions of microscopic molecules or study the popularity of electoral candidates, we see randomness, or at least apparent randomness, almost everywhere. In addition to phenomena that are genuinely random, we often use randomness when modeling complicated systems to abstract away those aspects of the phenomenon for which we do not have useful simple models. In other words, we try to model those parts of a process that we can explain in relatively simple terms, and we assume, true or not, that the rest is noise. To put this differently, we model what we can, and whatever happens to be left out, we attribute to randomness. These are just some of the reasons why it's important to understand how to simulate random numbers and random processes using Python. We have already seen the random module. We will be using that to simulate simple random processes, but we'll also take a look at some other tools that Python has to generate random numbers. Let's see how we can use the random choice function to carry out perhaps the simplest random process, the flip of a single coin. I'm first going to import the random library, so I type import random. Then we'll use the random choice function. We first need parentheses, and in this case we need some type of a sequence, here a list, to contain the elements of the sequence. I'm going to go with two strings, H for heads and T for tails. If I now run this code, Python will pick one of the two elements, head or tail, from this sequence. If I run this several times, occasionally I get a head, occasionally I get a tail, as expected. Often it's more useful, however, to relabel the sides of the coin with a 0 and a 1. So instead of using list of strings, as we did in the above example, we'll be using a list of two numbers, two integers, as our argument to the random choice function. I'm going to take this previous example. I'm going to replace the two strings with the numbers 0 and 1. And everything works just the same as before. The only difference is that now the outcomes are either zeros or ones. How could we use this approach to simulate the roll of a die? Since the outcome of a die is an integer between 1 and 6, we can use the same approach here. I'm going to look at my previous example where we picked a number either 0 or 1. Instead of having numbers 0 and 1, all I need to do is update the list. In this case, I have the numbers 1, 2, 3, 4, 5, 6, which are the 6 possible outcomes of a standard die. I can now roll this die simply by running this line several times. In this case, we're choosing one number out of 6, so this is how we can simulate a die. We could also implement this using a range object, and in that case, we just have to be careful when specifying the start and stop values. So instead of a list here, we insert a range. The first value has to be 1, and the stopping value is going to be 7. Remember that many Python functions like range stop before they hit the stop value. In this case, we specified the range object that will include the numbers from 1 to 6. Let's try running this example now a few times, and we'll see that it works just the same way as our list example above. When you explore the documentation for random choice, you'll find that you don't necessarily need to provide a list. Instead, any sequence object will do, and because range is a sequence object, you can provide that as an argument to the choice function. But it's worth taking a moment to think about what you're asking Python to do if you had used the following line. Taking the previous example, I'm just going to insert my range object inside a list object. I'm then going to run this line. See what's happening. We know that random choice expects a sequence, which is what you have provided, in this case a list. But that list contains only one object. What is that object? It's a range object. So when you run this line, Python will always return a range 17 object to you because that's the only object or sequence the list contains. I'm mentioning this here because it could easily lead to a programming error, although you can always try running your code in the interactive mode to make sure it does what you would like it to do. Let's build on this idea to explore a somewhat harder example. Imagine a situation where you have 3 dice, one of them having 6 faces, one of them having 8 faces, and one of them having 10 faces. How could you simulate one outcome for a process where one of these dice, chosen uniformly at random, is rolled just one time? Here's what I would do. First, I would think about choosing a die, and then, second, I would think about how to roll the die I just chose. Let's first implement all 3 die, and then the selection among them, and then we finally simulate the roll of the chosen die. Let's first construct a list of range object. We have our first object, our second object, and our third object. The first one needs to be a range 1, 7 object, as we saw before. The second one is a range 1, 9 object, and the third one is a range 1, 11 object. What we have now here is a list of 3 different range objects. If we'd like to pick one of these, we will use, again, the random choice function, so we need parentheses. And let's try running this code. This time we got the range 111 object, now we get a different object, and so on. So what this line of code does so far is it picks one of the 3 range objects uniformly at random. But as before, we can pick one of the numbers that's contained within a range object. So we can embed the code we have inside another random choice function. In this case, we're first picking one range object, and then we're calling random choice on whichever range object we happened to pick. And in this case, we get an outcome that corresponds to the process that we wanted. Why does this example work? Remember, everything is an object in Python. Here, the innermost random choice first chooses one object from a sequence, here a list of range objects. The outermost random choice chooses one of the numbers from the given range object.